Scientists trace South Georgia's giant ice history. South Georgia is an island of astonishing beauty, of imposing landscapes, and bewildering numbers of penguins, seals and seabirds. It also has some impressive ice fields, although none it seems quite like those of the past. Some 20,000 years ago the island glaciers pushed out 50 kilometers and more from their current positions, reaching to the edge of the continental shelf. The British overseas territory was in effect covered by a giant ice cap. This realization is reported in the current edition of the journal Nature Communications. It is the result of investigations of the seafloor by a team of scientists from the UK, Germany and Australia. We were able to find a tracer of this ice cap, a ridge at the outer margin of the continental shelf that's larger than all others, pretty much, and it's fairly contiguous, explained Dr. Alistair Graham from Exeter University. You see it to the west, to the north, to the east, and even to the south where we don't have much data. It's quite a surprise because many scientists had assumed any ice cap was quite small. Dr. Graham and his colleagues conducted sonar surveys around South Georgia using the British Antarctic Surveys (BAS) research vessel, the James Clark Ross, and Germany's RV, the Polarstern. These ships mapped the long deep troughs cut by ancient glaciers. Evident in these channels are the countless, telltale markings of bulldozed sediments known as moraines. But to fill out their picture, the researchers needed also to establish when these features were produced, and so they pulled up cores of seafloor material. Caught up in this mud and rock are the shelly remains of tiny animals that can be used to date the glacial deposits. What emerges from all this study is a story of a rapidly changing icescape, one that has been incredibly sensitive to really quite small changes in temperature. The investigation reveals that the giant ice cap was at its fullest extent at the height of the last ice age, about 19 to 26,000 years ago. Then, as the global climate warmed, the glaciers went into a fast retreat, pulling back to positions not far beyond the present coastline. A pulse of cooling about 15,000 years ago saw them briefly push forward, before deglaciation took hold again. In the last 10,000 years the ice cap has wobbled back and forth, but never really gone out much beyond the fjords, Dr. Graham told BBC News. And then in the 1950s, things seemed to go pear-shaped for South Georgia. The glaciers now are in a massive retreat, which could have quite serious implications for local ecosystems. With so many of the glaciers today pulling back onto land, they no longer provide as much crushed rock to the surrounding ocean as they once did. This potentially could put new constraints on the bioproductivity of the region, said co-worker Professor Dominic Hodgson from BAS. As they erode, South Georgia and the other subantarctic highlands put rock flour in the ocean, and that provides a supply of iron. Iron is the limiting nutrient, he explained. It gives rise to big blooms of plankton which then drive the ecosystem from the bottom up, from the plankton and zooplankton, to the krill, all the way up to the seals, birds and penguins. This is why you get this intense concentration of biota around South Georgia. It is an interesting question, however, as to what all this wildlife did when South Georgia was covered by a huge ice cap. Many of its bird species, such as the albatrosses for example, nest in burrows and so need some clear, ice-free land to breed. There are also some endemic animals, they exist nowhere else. For these creatures to have survived through the Great Glaciation there must have been gaps in the ice cap. The team is trying to establish where these refugia might have been. Another spillover from the study is determining what the South Georgia experience tells us about higher latitudes, such as the Antarctic Peninsula. The glaciated finger of land that juts up from the White Continent towards South America is already one of the fastest warming locations on Earth. Scientists who try to model its future behavior now have a new anchor point in their simulations thanks to this study. South Georgia shows us what the response is of an ice sheet to really very moderate changes in temperature, both in the ocean and the atmosphere, said Professor Hodgson. We can now take those responses and push them further south and get a very good idea of what might happen to the Antarctic Peninsula, and indeed any ice sheet that is close to its thermal limit,